Hi there everyone, welcome back to Dandelion Delphi tutorials. Today we're going to have a look at built-in functions that Delphi provides us with and that we can make use of in our code to make life a bit easier. In the Getting Started playlist, you created your own programs, but now it is important to go and download the data files from this link, as we are going to make use of programs for which I've already given you the interfaces for. The first function we're going to look at is random range, and this function will return a random number, so we can get Delphi to pick and generate a random number for us. In the round brackets, it requires two arguments. This is the range in which the numbers will be selected from. This will pick a random number from 10, including 10, up to 500, so it excludes our second argument in the brackets. Every function returns a single answer for us, and this answer is called the result. The result of each function has a certain data type, and it's important to declare variables that will store the result of these functions as the correct data type. So we're going to declare an integer number. I've called mine irandom, and the function has to be on the right of an assignment statement or as part of another set of code that we'll do later. Then random range, open brackets, the lower boundary. So let's say I wanted to pick a random number from 1 to 50. I will put 1 and 51, as the second argument will be excluded from the random numbers picked. Some of our functions, like random range, actually is contained in another unit that is not automatically added to your form. Should you have tried to add this code to your program, you possibly would get a red line there indicating an error. To fix that, scroll right to the top of your program and you will see a section called Uses. We are going to add to the end of Uses a comma, math, just before the semicolon that is already there. And that will allow us to make use of functions in the math unit. In the data files that you have downloaded, you will see a folder called Built-in Functions. Open that program and let's do the first activity together. In this program, instead of using buttons, we are going to use a menu. You can double-click on the menu and that gives you all the options and sub-menus of the programs that we are going to use. And if you double-click on the plus there, this is where we are going to code our first program. Nothing has changed from the button to the menu. We are just creating a different event of when code will happen. Read this question, and if you feel confident, you can press pause and try it yourself. We have been asked to store two random values, and this is where we're going to make use of random range. We need two variables because we need to store two values. Then we're going to calculate and store the answer if we add these two random values together. We are going to display the random values in these edit boxes here, and we're going to display the answer in that edit box on the right. We are also going to put a plus in the label here in the middle, and that label is called LBL operator. We will need two integer variables. I just called mine inum1 and inum2 to store the input from the random range. And then we also need a variable to hold the answer of when we're adding them together. Now, since we're adding two integer variables together, our answer will also be integer. So I've declared all three of them as an integer data type. Remember to put your comments here, input, processing, and output, and leave lines open between each. Random range is going to pick a random number from 1 to 100. I have to put 101 as the second argument because it's excluding that number, and that will be stored in inum1. In inum2, I'm going to have a randomly selected number from 101 to 200. Then I have to calculate the answer. I'm going to store the answer in iAnswer, and that's why it is on the left of the assignment statement. I will now add inum1 plus inum2 together, and my answer of those two numbers will be stored in iAnswer. In my output, I have to change the caption property of the label LBL operator to a plus. Then I want to display my two random numbers in EDT num1 and EDT num2. We're using the edit box here to display, and for that reason it's on the left of the assignment statement. Putting the randomly selected variables here on the right, both of them, inum1 is displaying in EDT num1 and inum2 is displaying in EDT num2. And finally, I'm going to put the answer in EDT answer. Remember, what we see is in the text property, so we will have EDT answer.text is assigned to iAnswer is an integer. For that reason, I will need to string that variable. It's time to test and run your program. If you don't have any errors, you will see the form in front of you. And we don't need input this time, so I'm just going to click on Math and then on the plus where I added my code, and voila! There I see a randomly selected number, number 9 and 137, and if I add them together, the answer is 146. Should I click on that menu again, I will see new random numbers being picked and the correct answer there. Also take note that I've changed the caption property of LBL operator to a plus. You won't necessarily get the same numbers as I do, as your program are also picking its own random numbers, and every time you click on there, new random numbers are selected, displayed, added together, and the answer displayed in there. At the back of my books you will find appendixes containing all sorts of functions that we can use in Delphi. You need to understand how to read these tables. This here would be the name of the function, and the number of arguments are indicated in brackets. The arguments each have to have a certain data type, and that I've indicated here with a single character. You will find the key here at the top. I is for integer, R for real, and so on. Every function returns a single result, and that result also has a data type that I've listed for you in the third column. For example, round will return an integer answer. Then I have included a description for you, as well as an example of should the variable contain the value 7.2, and I've used round in it, the result of that function would be 7. When we use these functions in the following activities, you are going to put a variable with a specific data type on the left of the assignment statement. That variable must match the data type in the results column. Then it will be followed by an assignment statement, the name of the function, and in round brackets a single argument or maybe more. String to int that we've used before is also a function, and inside of our brackets we need to put a string data type. In this case we use the edit box and the .text property that is string to convert this string entered into an integer to be able to store it as an integer result. So I have declared inum there. We can now use this variable on the right of the assignment statements in lines to follow, as it would now have a value. Let's look at an example of using square root of this number that was entered. If we look at the table here, you'll see square root needs one argument. This argument here can be either real or integer. What is important to note is that the result is always real. So the variable that I'm declaring here should be real for the square root of any number. If you think about the example of a perfect square, we know that 16 will provide us with an integer number. However, if we send it a number like 42, it's going to give us some decimal places. And that is the reason why we need to declare a real variable to store the answer or the result of square root, regardless of the argument being an integer or a real number. I can now further use our answer on the right of the assignment statements since it received a value on this line. There are two functions that would also need the math unit as we did with random range, one being called ceil and one is called floor. Both of these round the numbers, but ceil rounds this number up to the closest integer, ceil for ceiling, and then floor rounds the value down to the closest integer. Let's say the user entered 42 in the edit box, we store it as inum, and now we square root 42, my answer will be 6.480 and some other decimal places. That would now be stored in our answer. Now I can use our answer in ceil, and ceil will round that value up regardless of what the decimal places there would be. So anything from 6.1 would be rounded up to the closest integer, making it 7. I am going to store that answer as an integer as the result of ceil is integer. Floor will just do the opposite and take this number, rounding it down to the closest integer, and that would be 6. Also stored as an integer as the result is an integer. The rounding function uses rounding as we would in maths. So if it would be 7.2, it would be rounded down. If it is 8.8, it would be rounded up. So we don't have a lot of control as to which way it would round, and often we need to either round a value up or down. The only difference is when we want to round a value like 7.5, it will round up to 8 because 8 is the closest even integer. If I round 8.5, it will round down to 8 because 8 is the closest even integer. This is called Banker's rounding. The next function that is also in the math unit is round2, and it needs two values in the round brackets. The first one can be either real or integer, but the second one should be integer. The second argument that we send the round2 function indicates the number of places 10 to the power of, in this case, -1, that I want to round the number off to. You know that 10 to -1 is the same as 1 over 10. That means is 0.1. And for that reason, if I send it -1, it's going to round the value off to 1 decimal place. So if we send it our 6.48 value stored in our ans as the first argument with the -1, our result for this round2 function will be 6.5. If you send it a positive number, it is going to round it off to the closest 10 to the power of 3. And that means it's going to round it off to the closest 1,000. So if we take an example like this, the answer for that function would be 2,000. This is your time to practice. So go to the Math main menu and you will find a sub-menu there called ABS and FRAC. Make use of the tables and apply those skills to complete this question. Press pause and I'll show you the memo soon. When you're displaying, also add the labels so that you can see what you are displaying at that point. We have been asked to store a random number from -100 to -1. So therefore I am stopping there at 0 because 0 will be excluded. This will now contain a negative number. Now I need to add a real randomly selected number to this number to create a real random number. And I'm going to use inum, and I add to that the random function without any brackets. This will produce random real numbers, 0 point, and then a whole bunch of numbers after that I can store as are real. This is the variable that I'm displaying here as the random number, so at least I can see which number Delphi selected. Make sure that you display 4 decimal places for all of these numbers to see exactly what these functions do. We then had to use the ABS function, absolute value, to change this negative number into a positive number, and I've stored that as R positive. We also had to get hold of the decimal values of this random number, and I'm using frac, sending it R real, that was the value that was stored in R real. and I'm going to store that in my variable rfrac. The last thing we had to do was use the floor function to change the positive number and round it off, or rather round it down to the closest integer. I'm storing that as an integer number. You will see that I have used inum1 here again that I've used up there. You can declare a new variable, but I'm just overwriting that variable because I'm not interested in the value that it was here any longer. I'm not displaying it further, and after I've used it on this line, I'm really done with it. So I've just used the same variable because I was lazy to declare another one. When you are displaying in the rich edit, just make sure that you are displaying the correct variables. Make sure that you do all the activities of this program by following the descriptions in my book and use those tables at the back to guide you. Thank you for watching Dandelion Delphi tutorials. Hope to see you soon.